Hello everyone, welcome to my channel Mathsada and thank you for liking our videos. Today it's my third lecture on quadratic equation. In this lecture I will be covering quadratic expressions in details, and I have plotted the various graphs of quadratic expressions, and then I have derived conditions when a quadratic expression will be always positive or always negative. And the next lecture, which is very important, that is location of roots. It is very important one, and kids always get confused here, so please don't miss these two lectures. So let's start. Ax square plus bx plus c equal to 0, that is equation when it is equal to 0. So equation will have two sides, right? This side and this side, left right. Expression is what? It is ax square plus bx plus c. It is quadratic expression, right? And generally we give name to a quadratic expression. So we will be giving name to this. This is y is equal to ax square plus bx plus c. Today we are going to discuss this expression and its graph. Before I plot ax square plus bx plus c, we will be looking at some easy graphs. So y is equal to x square. How graph will be? Graph is same method. You take x, y, put all the points and then plot it, right? Since it is very easy, I will be doing it very quick. X equal to 0, y equal to 0, so this is point. X is equal to 1, y is equal to 1. X is equal to 2, y is equal to 4. X is equal to 3, y is equal to 9. Very high, right? Similarly, minus 1, it is 1. Minus 2, it is 4. Minus 3, it is 9. So it is, if you connect them, it will be like this one. This is y is equal to x square. This is called parabola, and this parabola, it is called open upward parabola. So we just saw very quickly what is graph of y equal to x square. Let us take another graph. Y is equal to minus x square. If you plot them, this graph, everything will be same. It will be just opposite of this blue curve, that is y equal to x square. How it will look like? It will look like this one. So this means what? This is plus sign here, it is open upward, right? It is minus x square, it is open down. This means coefficient of x square decides it will be open upward or open downward. So if a is greater than 0, it is what? Open upward. If a is less than 0, what it is? It is open downward, right? Let us look at some more graphs. If I want to plot this, y is equal to x minus 1 square, right? So how to do it? When it will be 0, it will be 0 at x equal to 1, so it becomes 0 at 1. At x equal to 1, it becomes 0. At x equal to 0, it becomes minus 1 square, that is 1. X is equal to minus 1, it becomes minus 2 square, that is 4. It is like this one. X is equal to 2, it becomes 1. X is equal to 3, it becomes 4. So graph is like this one. Yes. This is almost same as y is equal to x square, right? Only thing is it goes shifted by 1 unit. So this lowermost point, this has a name, it is called vertex. So vertex is at which point? When this becomes 0. It becomes 0 at x equal to 1. So vertex of this graph is at 1. This is y is equal to x square, or you can say it is x minus 0 square, right? So it becomes 0 at x equal to 0. You see vertex at 0. So now if I try to plot this one, we observe something. You see how it works. Y is equal to minus of x minus 2 square. I want to plot this. So from the previous observations, what I see, it is minus, so it will be open downward. And where it becomes 0, it becomes 0 at x is equal to 2. So it is what? Vertex. So these two information will be sufficient to plot the curve. Why? Because I know curve will be always parabola. So vertex and downward, let's use this and get the graph. So at 2, vertex will be here, and that is downward, so it will be like this one. It is y is equal to minus of x minus 2 square, right? You see, now we just learned how to plot graph. Let's see more graphs. If I want to plot y is equal to x square plus 1, what we will be doing? We know graph of y equal to x square will be, so y equal to x square plus 1, we will be using graph of y equal to x square. There is something called transformation of graph. We will be learning it in class 12th in relation functions chapter, when we learn that it's very easy to plot graph of x square plus 1 from graph of x square. So this part we will be doing it, covering it today also. Let's see. So graph of x square is this. Here it is x square plus 1. So at x equal to 0, what it will be? Y will be 1. So 0 comma 1. So it will be here. At x equal to 1, it will be 2. So here. At x equal to 2, it will be 5. So here. Similarly, this side at x equal to minus 1, it will be 2. And likewise, so graph will be like this one. What do I see? Each point has been shifted by 1 unit. So this is 1 shifted by 1 unit. If it is 2, it will be shifted by 2 unit. If it is 5, it will shift by 5 unit. If it is minus 1, it will shift by minus 1. So it will be dragged down by 1 unit. Got it? So this means we learned 3 things. If A is positive, open upward. If A is negative, open downward. Second thing we learned is vertex, where the square term, means this term becomes 0, that gives us vertex, right? Here it is 0 at 2, 2 is vertex. Here it is 0 at 0, you see, at x equal to 0, it is vertex, right? And third thing we learned, if we add some constant to that, it goes up and down. Using these 3, let us plot some graph here, then we will be moving ahead. So I have taken 3 expressions, y is equal to x square minus 1, second is y is equal to minus x square plus 3, and third is y is equal to x square plus 2x plus 2. Let us see how to plot these 3. If we can plot all these 3, this means we can plot any quadratic expression. So y is equal to x square minus 1, so it is what? It is x minus 0 square minus 1. So vertex is 0. And then it is what? Y, and it is positive here, right? So it is open upward. Open upward, vertex 0. So it should be like this one, open upward, vertex 0. So it should be like this, right? But what it says, it is minus 1. So it will come down by 1. So it will be like this one, right? So we got this is y is equal to x square minus 1. Now next is minus x square plus 3. So it is what? It is minus x plus 0 square plus 3. It is open downward, vertex 0. So it is vertex 0, open downward, right? Like this one. But then what it says, goes plus 3, goes up by 3. So it will be like this one, right? So it is graph of y is equal to minus x square plus 3. Then third one is not in the format. It is not in the format square, right? So I see 2 x terms. What I will do? I will simplify it to perfect square format. If you do it, it is x plus 1 whole square plus 1. I did not do it. You can see it. Both are same. Now I can see vertex is minus 1 and it will go up by 1, okay, and this is plus, so it is open upward. Enough information. Open upward, vertex is minus 1. So vertex is minus 1, open upward, then 1 up. So it should be this one and then 1 up. So it will be this one, right? So you got graph of x plus 1 whole square plus 1, third one, right? Is it okay? So I think you learned it here. Now moving to general expression. Now I want to plot graph of ax square plus bx plus. So how to do it? This is kind of third one, that is x square plus 2x plus 2. So what I will be doing, I will be converting to perfect square, take a common. So it is x square plus b by ax plus c. You remember, I am doing this perfect square second time. First we did while deriving that Siddharachar formula, right? Now what we do, we will be, you go through that, so I am doing it quickly here. So once we convert to perfect square, this is the expression. Now what is vertex? Make perfect square term 0. It gives vertex x is equal to minus b by 2a. And when you put x equal to minus b by 2a, what is the value of y? It is, this becomes 0, it becomes minus of b square minus 4ac by 4a. This is y value at that x equal to minus b by 2a. It is what? D. So it is minus d by 4a. So vertex is what? Vertex is minus b by 2a comma minus d by 4a. So we got vertex, and then once we get sign of a, we can plot it. But we have general expression, so we don't know how a will look like. So move ahead with this. So we know vertex. Now how to plot the graph? So we need to take condition when a is greater than 0. When a is greater than 0, then graph will be open upward, right? Now vertex is minus b by 2a comma minus d by 4a. So it will be somewhere like this one. If a is positive, if it is the vertex, graph will be like this one. Correct? So it can be this, or it can be, or vertex can be on the x-axis, so it can be this, or vertex can be like, vertex can be here, so it can be like this. So three situations, all a positive. This is minus b by 2a comma minus d by 4a. This is minus b by 2a comma minus d by 4a, and this is minus b by 2a comma minus d by 4a. Now see, this point minus b by 2a cannot be on, should not be always on positive, it can be anywhere. So I have just taken one reference point, it can change. Okay. So now what I see, this is, it touches x-axis here. This means what? Y becomes 0 here. Correct? Here it crosses x-axis here, so y becomes 0 at these 2 points. So points where it touches x-axis or intersects x-axis, those are what? Zeros of that quadratic expression, right? So this point is 0 of that quadratic expression, 0. Here this is 0 of the expression, this and this. So I can say this is alpha and I can say this is beta, right? So this situation, it is no roots. So we can, from graph we can also decide condition on this. So here when it is open upward and does not touch x-axis, it goes, it is always above x, means what? Minus d by 4a should be positive, and what we know, a is positive implies minus d is positive, implies d is less than 0. What is the condition for, this is condition for what? This is condition for no roots. See, it does not intersect axis at any point, so no roots. So graphically we have also found if d is less than 0, there will be no root, right? Here when it touches x-axis means what? Y is 0, right? So this means minus d by 4a should be equal to 0, then it will touch the x-axis, means what? D is equal to 0. You see, if d is equal to 0, it touches x-axis at only one point, so it will have both the roots same at this point, right? Then this situation, when it is coming below x-axis, means what? This y, this length, that is minus d by 4a, it should be less than 0. So minus d by 4a is less than 0. A is positive, so minus D less than 0. This means D is greater than 0. When D is greater than 0, we know what is the situation, two roots alpha and beta, right. So graphically we can actually show these conditions less than 0. This is when A is less than 0. So let's see how it works. So I have not plotted y-axis because that vertex can be anywhere, so this is more correct one. Now when A is less than 0 means what, graph will be open downward like this, right. And then it can be like this situation, it can be like this one, right. This is the vertex, that is minus b by 2a comma minus d by 4a, right. Or it can be this situation where it touches the x-axis, or it can be this situation where it does not touch its x-axis at all, right. So it is minus b by 2a comma minus d by 4a. Vertex is always same, right. This one minus b by 2a comma minus d by 4a. So you can see it intersect x-axis at 2 points. These are zeros of the expression, so you can say this is alpha and this is beta. So two roots. When it can have two roots, when graph is this one and it is above axis vertex, then it can intersect 2 points, right. This means what, this height should be positive, right. So this means what, minus d by 4a should be positive. Now minus a is negative, so minus d by minus is greater than 0. So what it is, d is greater than 0. See, again same thing came, d positive means two common roots alpha beta. Here when it touches x-axis means what, this minus d by 4a, it should be what, it should be 0. So minus d by 4a is equal to 0. So d is equal to 0 for common roots, for equal roots. Now here what should be minus d by 4a, it should be less than 0. So minus d by 4a, it is negative, so negative less than 0, d is less than 0 for what, no roots. See, it does not intersect x-axis anywhere, so no roots. Clear. So this means this is how we will be plotting graph of general quadratic expressions. So we will be discussing this situation and similar situation from the previous one, because these are special cases and we are going to derive some deduction from here. So let's see. When d is less than 0 and a is greater than 0, how graph will look like? It will be open upward, d less than 0 means no roots, so it will be like this one. Graph will be like this one, right. Why? D a greater than 0, open upward, d less than 0, so it should not be like this one. Why? Otherwise there will be two roots, so not possible. Or it cannot be like this one also, because then there will be roots, right. So this is the graph when d less than 0, correct. So what we see, this means this graph is always above x-axis, right. You see, always height is positive, correct. So what means what does it mean? This means y is always greater than 0 in this situation, or you can say ax square plus bx plus c is always greater than 0. So I will write, when d is less than 0 and a is greater than 0, ax square plus bx plus c is always positive. This is a very, very important concept. We will be using it very frequently. Now second situation is when d is less than 0 and a is also less than 0. Since a is less than 0, it will be open downward, kind of this, right. And d less than 0 means it will not be touching or intersecting x-axis. So how the graph will look like? Graph will look like this. Like this one. This point will be what? This will be minus b by 2a comma minus d by 4a. Now we will not forget this vertex, minus b by 2a comma minus d by 4a. So what do we see? Graph is always below x-axis, means always negative. Here I can say y is less than 0 or ax square plus bx plus c, always negative, right? So if I write here x square plus x plus 1, this, what we know about this, this is, what is d here? D is equal to b square, that is 1 square minus 4, that is equal to minus 3, less than 0. And what is a? A is 1, that is greater than 0. So d less than 0, a greater than 0, graph will be always above x-axis. So it is like this one, right? It will be what? Always positive. So y is equal to x square plus x plus 1 is always positive. That's what we learned today, right? So now moving ahead. So what is the sign when d is positive or 0? Let's see that also. We are looking at the situation when a is greater than 0. So first situation is this one, right, where there are two roots, alpha, beta. This is what? When d is greater than 0. When d is greater than, what we see, this side quadratic is positive. Here it is between alpha and beta, you see it is below x-axis, this is negative, and again after beta it is positive, correct? So this means when d is greater than 0, somewhere y is positive, somewhere negative, somewhere positive, correct? Second situation is this. When d is equal to 0, graph will be like this one, touching x-axis, right? So in this case, what will be this? This side it is positive, here it is 0, and this is positive, right? So graph is somewhere positive, somewhere 0. Third situation, what we discussed just in the last slide, what we saw that this is when d is less than 0, like this one. It does not touch x-axis or intersect x-axis, right? So what we see, it is always above x-axis, so it is always positive. We can do same thing for negative. For negative, graph will be like what? I am plotting it on this one only with another color. So when a is less than 0, graph will be like this one, correct? Like this one or like this one, got it? So this means what? It is again when a less than 0, it is what? Always negative. We discussed in the last section, clear? So moving, now I am giving you some questions to plot some curve, do this, and then we will move to another section. Try to plot these three curves. If you can plot this, means you got the concept very well. When you try to plot it, what are the points you need to focus? You need to find vertex, and then you need to say sign of a. If you can find these two things, you can plot all these curves. So let's move to a question. So how to solve this? Lambda x square plus 3 lambda plus 4 is always positive. A quadratic expression is always positive when it is true. This is when this is x-axis and this is the curve, right? It is always positive. It is somewhere 0, it is somewhere positive. So this is not the case, this is not. We are looking for this one, right? So this is true when what? D is less than 0, and then what? It is should be open upward, a greater than 0. So these are the two conditions. So a greater than 0, what is a here? A is lambda, that is greater than 0. What is this? This means lambda is 0 to infinity. Then second is what? Second is d is less than 0, that is b square minus 4ac, that is 9 minus 16 lambda square is less than 0. How to solve this? Using sign scheme. So what you will do, you will factorize it. It is 3 minus 4 lambda into 3 plus 4 lambda less than 0. Critical point 3 by 4 minus 3 by 4, right? So now plot number line and apply what? Apply sign scheme. Minus 3 by 4, 3 by 4. Then what you see? it is highest power of lambda, this lambda square is having negative sign, so it should start with negative, then positive, then negative, right? Now you are looking for less than 0, negative, this means this and this. So what is the answer? Minus infinity to minus 3/4 open, union 3/4 to infinity open, second. And then what you need to find? You need to find intersection of 1 and 2, right? So find intersection. Number line first is 0 to infinity, bubble mark here. Then second is what it says, less than minus 3/4, so this side. And then second part of it is more than 3/4, so 3/4 to infinity, bubble mark. I can see this part is common, right? That is our answer. So 3/4 to infinity, this is our final answer. So if lambda is between 3/4 to infinity, then this expression will be always positive. This is where I will end today's class. Thank you everyone for watching this video. If you like this video, please like it, share it, comment on the comment section and subscribe it. Thank you.